Dear students, good day to all. Today also we going to discuss three cylinder sequence such as A plus B plus B minus C plus C minus A minus. You can take this sequence for the following drilling applications also. So previously we see the three cylinder sequence. There's a C cylinder which is used to eject the workpiece from the workstation after the drilling operation completed. So here we use the C cylinder to drill a countersink hole. First normal hole will be drilled by B cylinder and countersink hole will be drilled by C cylinder. So the sequence is like happen. By the way, A cylinder extend to clamp the workpiece, B cylinder extend to put a normal hole on the work. After B cylinder will be retract and C cylinder extend to put a countersink hole on the workpiece and C cylinder will be retract. Then A cylinder will be retract to unclamp the piece. So this is the sequence happen. So as usual you need to do the first step. One is write the sequence of operation and draw a step diagram. To create a step diagram for all the circuit created, I will show you a video for a separate video for how to create a step diagram. That's not too much difficult. So step 2, in the given sequence. So when you take it as two groups, you can split it into 2 3 sequence: A plus B minus C plus C minus A minus. So if you consider like that, B plus B minus 0 group 1 and C plus C minus A minus. C minus A minus as group 2. So here you can look at group 1 and group 2. I have the same cylinder sequence. I cannot do like that because A plus will be happen after A minus. So I cannot write A minus A plus B plus and B minus C plus C minus. So if you write like that, that way also a group contain the same cylinder sequence. So I can do only a group should contain a two sequence. Therefore, I am going to create three group sequence. A plus one group, B minus A minus, sorry, B minus C plus, B minus C plus as group 2, minus A minus as group 3. Next, step 3, number of power lines is equal to number of. So totally I have 3 groups, so I require 3 power line. Next step, number of valves. First one is number of pilot operated 4/2 TCV for cylinder control is equal to number of cylinder. So totally how much cylinders, that much amount of pilot operated TCV also required. That should be 3. Second one is number of limit switches. That's equal to number of cylinder into I require 6 limit switches. 3, 6 limit switches. 6 limit switches. So here each cylinder require 2 limit switches to identify the extension and retraction position. So I require total 6 limit switches. Next I require number of changing group changing valves. So number of group changing valves equal to number of minus 1. So 3 minus number of group minus 1. 3 minus 1. I require 2 group changing valve. Okay. So step 5 is construct the circuit for the given sequence. Okay. So I took the same sequence. So I require 3 cylinders, 6 limit switches, 3 DCV, and I required one more group changing valve. So totally I require 2 group changing valve. So I required 2 group changing valve. Required 2 group changing valve. I required 2 group changing valve. Okay. So all the DCBs will be connected with main power source, and the pilot signal provided from that group changing valve is the group changing valve 1, and this would be group changing valve 2. Just write it as to avoid confusion. DCB 2. I have power line 1 as a 4 port, power line 2 as port 2, and again group changing wall 2 port will be power line 3. So I require only 3 power line. So I can change the wall configuration. That should be closed center. Okay, that should be closed center. Closed center. Sorry, closed center. That should be closed center. Okay, because from port 4 only I got the power line. When the group changing wall to position 1 will be changed. Okay, what is the first sequence of the given process? That be A cylinder extern. A cylinder only extern before A cylinder only extern only after the A cylinder retract. A cylinder retract will be in group 3. Okay, so you got the signal from A cylinder retract to change the group changing wall position 1. Okay, changing wall position 1. So you get the power output from the power line 1, that is 4 port. So the first sequence is A cylinder need to extend. After that, A cylinder extend, B cylinder need to be extend. This connection need to be given. After B cylinder extend, the group need to be changed. Give it from B cylinder extension, you get the input signal. So this will change the power line. Therefore, group changing wall position 1 will be changed. Position 1 will be changed to position 2. The second group, the first sequence is B cylinder will be retract. This will be power line 2. So first sequence B cylinder will be retract. After B cylinder retract, what is the next sequence? C cylinder to be extend. So C cylinder will be extend. After C cylinder extends, what is the next sequence? It's going to change to group 3. So you need to change to group 3. Okay, so here you can set the configuration. That should be spring center. So whenever I got pilot signal, I can actuate the third group power line. Whenever there is no pilot line, whenever there is no pilot line, whenever there is no pilot line, so group 3 is not actuated. So group changing wall 2 will become to its initial position through the mechanical actuations with the help of spring. Okay, so port 4, from port 4 in the group changing wall 2 I got the third power line. So third power line, from the third power line I got the first sequence in the group 3 is C minus. So here the C minus need to be connected. C minus need to be connected. After C minus, what need to be happen? A minus need to be happen. So this will be happen. After A minus, what need to be happen? it need to be changed to group 1. So the sequence will be happen as usual. Now we give the connection to the limit switches from the respective power lines. Group 1 A plus and then B plus will be receive the power input from the power line 1. So this is the power line 1. See power here. Okay. Doing it a next B plus I give the connection to the power line 1. Okay. So A plus and B plus receive the power signal from the power line 1. Similarly, B minus and C plus will be receive the power line from power line 2. Will be the power line 2. This will be the power line 2. This will be the power line 2. From the power line 2, the B cylinder retraction limit switch get the power source. And then C plus will be the receive the power source from same power line 2. Okay. C plus also receive the power line from same power line 2. Next, from power line 3, I need to connect the limit switches C minus and then A plus. This will be the power line 3. C minus receive the power from power line 3, and also A minus also receive the power from power line 3. Okay, so now we completed the given sequence. This will be set as vent, external vent. So now we try out the simulation. When you push the push button, okay, wait, there is a mistake. So here I did one mistake. The DCV2 wall cannot connect with the power source. This DCV receive the power source. This DCV receive the power source. This DCV receive the power source. DCV receive. Now we try out the simulation. If there is a mistake, Okay, students, as usual, when we do the simulation, the sequence will not happen as per the process we decide. Okay, actually, what happens, the C cylinder will be externed first, okay, and then retract. So the power line 3 has give two inputs to the two limit switches such as C minus A minus. So after C minus, A minus will be happen. After A minus, what will be happen? The group will be changed to group changing wall position 1. So in group changing wall position 1, it got the power signal to actuate the A plus first. So in the meantime, I have the input signal from uh, I have the input signal from the C minus limit switch. So the DCV1 get locked. Okay, so therefore we go for step counter method. Okay, so there is a wall locking condition arising cascade circuit when we go for a complex circuit like this. Okay, so that complex sequence in manual kind of operation can be eliminated through step counter method. So next we will discuss step counter method. Okay, in previous simulations such as here we have a three group sequence for the three cylinder three here we have the three groups for the six sequence of operations. So similarly we have also previously we discussed similarly we discussed this two group sequence. Okay, here I need to do a one more alteration here. So you need to enable the initial portion of the group changing valve as first portion. Okay, first portion should be the initial portion. So when you enable this first portion as initial positions, so the automatic extension of C plus and C minus not happen. Okay, so here you can look. So when you press A plus will be happen, B plus will be happen, B minus will be happen, A minus will be happen, then C plus and C minus will be happen. Okay. So clamping of the workpiece, drilling of the workpiece, unclamping of the workpiece, ejection of the workpiece from the workstation. Okay.